So let's continue our discussion on variables and primitive types. We'll first begin by talking about the rules of naming identifiers in Java. So you cannot just name variables whatever you want. They need to follow a specific set of rules that Java has laid out for us. First is that your identifiers cannot be multiple words. They have to be a single word. If you want to make them multiple words, you have to exclude spaces, right? So if I want to say int, my age equals 18, you can't do that because there's a space, and Java's not going to like that we have to say my age. So in that sense, it's a single word because there are no spaces. Also, your variables need to start with a letter, an underscore, or a $ symbol. So my age or $ my age is valid. Anything other than that is not valid. Secondly, I can't call my variable int because the word int is already being used. It's a special keyword that's used by Java, so we can't use that to name our variable. So if you need to name your variable int, you'd have to say like int or something. It just cannot be int. It cannot be class, double, things like that. It can't be a reserved keyword. If you want to use a number in your variable name, and again, I'm using variable names and identifiers interchangeably. They basically mean the same thing. The correct terminology is identifier. If you want to use a number in your identifier, you can say like, I don't know, my 8 dogs names equals, and then you can list them out. Fortunately, I don't have any dogs. If you want to include numbers, you can, like this, where the number is in the middle of the identifier. You can also include it at the end, right? You can say, you can add it at the end. But again, you just cannot have a number in the beginning. This is invalid syntax. Okay, and your identifiers can be of a certain length, right? So I say int, this actually would be invalid. We can make an extremely long variable name. In fact, it can have 65,000 characters around there. Although, you should never ever need an identifier that is that long. If you are, you're doing something wrong. So don't, your identifier should be short and descriptive. Not too short. You don't want them to be like, int a. That's not very descriptive. Int age is better, right? You want them to be short but descriptive. You don't need that many characters for an identifier, but if for whatever reason you do, and you almost always will not, but if you do, you have 65,000 characters of room. Also know that identifiers are case sensitive, meaning that if I had something like, my age and int my age, right? These are completely different variables. They're not the same thing because it's case sensitive. And also, you're totally allowed to have uppercase and lowercase letters inside of your identifier, right? So if I said int, my name, see, I can have an uppercase n and lowercase n. Now there are different conventions for making identifiers, but we use what we call camel case, right? So it's my age. It's basically the first, if you have multiple words, again, without a space, right? If you have multiple words, the first word, the first letter of the first word is lowercase, but every first letter of the next word, of every other word, is going to be uppercase. So if we say like string my, right, the N and the D are capitalized because they're starting new words. It's just an easier way to help distinguish, which words are which inside of an identifier. Okay, so now we're going to start talking about primitive memory capacities. We have to remember that the primitive types have a certain amount of space allocated to them. You cannot fill up, say, a byte with a number that is greater than 128 because of the way that bytes are holding information and the capacity that they have. So let's go over all of them and cover how much capacity they have, right? So the first one is a byte. So it's an 8-bit signed 2's complement integer, meaning that you have your 8 bits would give you up to your 256 values, but because it's signed, you can only go up to 127 and negative 128. All right, so the next is the short, right? And this is a 16-bit signed 2's complement integer. Okay, so it has double the amount of bits that a byte has, right? But that doesn't mean that it has double the amount of capacity. It actually, remember, these are powers of 2 here. So instead of having up to 127, you have up to 32,767, and all the way down to negative 32,768. Okay, so much more capacity than a byte. It takes up 2 bytes or 16 bits, and again, it's signed and it's a 2's complement integer. The next is the int I. Okay, so it's a 32-bit signed 2's complement integer. 32-bit meaning 4 bytes, signed, which means you get negative, positive values. Its range is all the way from negative 2 to the 31, and then its maximum values all the way up to 2 to the 31 minus 1. So much larger range of values that you can hold. The next one is the long. So the long is a 64-bit 2's complement integer, 8 bytes. This can hold anywhere between negative 2 to the 63 all the way up to 2 to the 63 minus 1. So again, even larger than an integer. You can hold huge numbers inside of a long. Now let's cover the character. The char is a 16-bit Unicode character. Again, I called this an int in the last video. You can treat it like ints. You can treat them like integers, right? You can do math with them and all that. So it is a 16-bit Unicode character, meaning it's 2 bytes, and it has a minimum value. It has a minimum value of U0000, and this is just a 0, and a maximum value of UFFFF, or this is 65,000. Okay. And these code things that you see here are just characters. They're just different characters. You can find them all on the, well, you can find some of them on the ASCII table. But remember, this is not ASCII. It's not just ASCII, it's Unicode, so it has a lot of other characters that you can use. The next is the double. So the double is a 64-bit 754 floating point value. Okay, so very precise, and it's 64-bit, meaning 8 bytes, so it can hold a lot of information inside of it. It can hold pretty big numbers. All right. Next one is a float. This is a 32-bit 754 floating point value. So again, it can hold decimal places, but just not with great enough precision because it can't hold as much information as, say, a double. Okay. So lastly is the Boolean. Right, so we say Boolean. Right, so the Boolean only represents 1 bit of information. And again, 1 bit because you only need 1 bit to represent true or false, right? It's just either it's 0 or 1. That only takes 1 bit. However, we can't technically say that a Boolean is 1 bit because its size isn't something that can be precisely defined. But it is true that it represents 1 bit of information, but the actual size of a Boolean is, again, you can't precisely define it. Okay, so that's pretty much it for the basics of variables and primitive types. In the next sets of videos, we're going to start talking about operators.